Welcome to today's class. Today we'll be learning about retrosynthetic analysis of aldol products. Retrosynthetic analysis of aldol products. And we will be trying to answer the question of determining the carbonyl compounds that are required for synthesis of a given target molecule. And so we need to recall that when we have an aldol reaction normally takes place between takes place in carbonyl compounds, and mainly these carbonyls are the ketones and the aldehydes. So this is addition reaction that takes place mainly in aldehydes and ketones. And so the product for a carbonyl for aldol reaction is either one, we have a beta hydroxy compound, which can be a beta hydroxy aldehyde or a beta hydroxy ketone. And number two, the product can be what we call an alpha beta unsaturated compound, and again the unsaturated compound in this case can be a ketone or an aldehyde. And we also need to remember that this alpha beta unsaturated compound are obtained or is obtained when the initial beta hydroxy compound undergoes dehydration. When we have the product, which is the actual aldol product, which is the beta hydroxy compound, if the compound undergoes dehydration, which is a loss of water molecule, then what is formed is a beta hydroxy unsaturated compound. And so when we have to carry out a retrosynthetic analysis in order to identify starting materials required for synthesis of a target molecule, then we need to inspect the target molecule, and if the target molecule happens to contain a beta hydroxy carbonyl or an alpha beta unsaturated carbonyl, then that's an indication that the target molecule must have been or could have been synthesized using an aldol reaction. And therefore the question we will be trying to answer today is how to determine the starting materials or the carbonyl compounds that are required to make aldol products. And this we will be doing through what we call the retrosynthetic analysis, that is working backwards from a target molecule so that we are able to identify the starting material. So we will be having these four examples here, the molecules A, B, C, and D, and we will carry out a retrosynthetic analysis in order to try to identify the starting materials that are necessary for the synthesis. So starting with the first molecule here, which is CH3 So starting with the first molecule here, which is having a formula of CH3, CH, double bond, CH, and carbonyl, carbon and hydrogen, the aldehyde functional group. So if we analyze or check the target molecule, this is the target molecule that we need to make, and we will realize that this is a compound that is having unsaturated carbon at it's unsaturated at alpha and beta position. So unsaturation at alpha beta position is an indication that the compound could have been synthesized or made by Aldol reaction. And so in order to carry out the retrosynthetic analysis, we work backwards in order to get the starting materials for the reaction. So in this case, having seen the that the molecule is an alpha beta unsaturated aldehyde, so retrosynthetic analysis in the first step, we should be able to be viewing the compound, the molecule to have come from a beta hydroxy carbonyl compound, and therefore working backwards we will have CH3, CH, OH, CH2, and the carbonyl, carbon and hydrogen. So working backwards, we go through the beta hydroxy aldehyde, the beta hydroxy aldehyde. So what we have done is we have done what is called a functional group interconversion, and this is a conversion that requires the dehydration, which is a loss of water molecule, so that to come from the beta hydroxy compound to the alpha beta unsaturated compound, we need to lose a molecule of water. Then still working backwards, the beta hydroxy compound, we should be able to be seeing it as having come from an aldol reaction, and therefore working backwards we need to disconnect a CC bond, a carbon-carbon bond, and the carbon-carbon bond that we will be disconnecting is the bond between the alpha and beta carbon. We disconnect the bond that is between the alpha and beta carbon, because this is the bond that is formed when we have an aldol condensation reaction. And so when we do this disconnection, it will reveal that the carbonyl compound that was used in making this target molecule here is an aldehyde, and the aldehyde is the one having CH3 COH, which is an aldehyde molecule, the one we call ethanol. It's the one called ethanol. And so ethanol is the starting material that is required to make the target molecule that we have in the first question. For question number 2, again at question number 2, looking at the molecule that we are having in question, we are having a molecule that is an alpha beta unsaturated carbonyl, alpha beta unsaturated carbonyl, and therefore that's an indication that the molecule, or the target molecule, in this case this is the target molecule, that the target molecule was synthesized from or using the aldol reaction. And so we carry out the retrosynthetic analysis in order to identify the starting material or the carbonyl that is required for its synthesis. So this is the molecule with a double bond at alpha beta position. And so in our retrosynthetic analysis, first we will do what is called a functional group interconversion. And the functional group interconversion is the one of dehydration. And when we do functional group interconversion, we get an intermediate product of retrosynthetic analysis, where we have that benzene ring and the aldehyde functional group, but now at alpha and beta positions. At alpha and beta position, we bring back the OH water molecule, and so the molecule that we are having after this functional group interconversion is a beta hydroxy compound, a beta hydroxy compound. So once we have the beta hydroxy compound, then this is further a clear indication that the target molecule was can be synthesized by aldol reaction. So further retrosynthetic analysis now shows that we can disconnect that CC bond, and that CC bond that we are disconnecting is the one that can be made by aldol reaction. Aldol reaction will be able to give us that bond, because when we are doing our disconnection, we must do with known and reliable reactions in mind. So that disconnection reveals that one of the starting materials for this reaction was benzaldehyde, while the other one is CH3 and CHO. So this is benzaldehyde, and this is ethanol. So these are the carbonyl compounds that are required to make our target molecule. So this is an indication that this target molecule was made from a mixed aldol reaction, where one of the starting materials is a benzaldehyde, and the other one is ethanol. For our case number 3, the molecule we want to synthesize is CH3, CH2, carbonyl carbon, CH2, and OH. So this is again If we refer to this carbonyl functional group here, this is a case of where we are having this position here is the alpha position, and this carbon is the beta position. So we are having an OH at beta position. So the target molecule here is one that is having at beta position, we are having a hydroxy substituent. So it is a hydroxy compound, a hydroxy, beta hydroxy compound. Again, this is a clear indication that the target molecule can be made or was made by Aldol reaction. So as we have said before, is that we need in this case to do a retrosynthetic analysis in order to identify our starting materials required for the synthesis. And as we said before, in this retrosynthetic analysis, we need to identify where we are having the alpha and beta carbon, because this is where the bond that is formed in aldol reaction. So in the process of our retrosynthetic analysis, this is the bond that we need to disconnect. So in our retrosynthetic analysis here, we will do a CC bond disconnection, and when we disconnect that bond, so the bond is here. When we disconnect the bond, is a CC bond, and the bond can be made back using aldol reaction. And so this reveals that the required reagents or starting materials for the reaction is one is CH3, CH2, carbonyl carbon, and CH3. While the other one is the other one is an aldehyde. So it is an aldehyde having one carbon, so HCO. So this aldehyde is the one we call formaldehyde. While the ketone here is the one that is called propanone. So if not propanone, the ketone there is not propanone. The ketone is having how many carbons? Carbon 1. It is having carbon number 1, number 2, number 3, and number 4. So the carbons are 4, and so it is butanone with the with the carbonyl carbon at position 2. So it's 2-butanone. So if we look at the target molecule and we count the number of carbons which were there or which are there, we have carbon number 1, 2, 3, 4, and 5. So the target molecule has 5 carbons, and therefore that can be made from a carbonyl compound, one having 4 carbons and the other one having 1 carbon to give the 5 carbon. So through that retrosynthetic analysis, we are able to determine what starting carbonyl compounds that are needed to make an aldol product. So our last example here is also the same question. We are to identify the carbonyl compounds that are required to make this product. This is our target molecule. And in the target molecule, again, we are able to identify that relative to the carbonyl carbon, we are having a double bond at alpha beta position, indication that this is a product that is made from an aldol reaction. So we do a retrosynthetic analysis so that we identify the starting materials, and the first thing we are going to do is to do a functional group interconversion. Functional group interconversion. And the functional group interconversion is a dehydration, because we should be able to see that the double bond was made from a beta hydroxy compound through a dehydration process. So functional group interconversion of the target molecule gives us this molecule here. The carbonyl carbon is there, and the benzene ring. So at beta position we have OH group, and there's a hydrogen here. So again, remember that the positions, the alpha carbon and the beta carbon, are key in our retrosynthetic analysis. So once we have converted the molecule so that we are having our beta hydroxy compound, the next step of our retrosynthetic analysis is to disconnect the carbon-carbon bond, and we know very well that that carbon-carbon bond can be synthesized using the Aldol reaction. So when we do that, that reveals that the compounds that are required in this synthesis is the molecule with the benzene ring, and when we disconnect at that point, that reveals an aldehyde functional group. So this is again a benzaldehyde. And the other component is the benzene ring and a keto group here. And so this is our second carbonyl compound that is required in this synthesis. So the process of retrosynthetic analysis for the aldol products is simple and straightforward. All we need to do is to identify the functional groups, which we have said that an aldol product is expected to have at beta position a hydroxy group. So whenever we recognize an hydroxy compound, a hydroxy ketone or a hydroxyaldehyde, a beta hydroxy ketone or aldehyde, then this is an indication that the molecule or the target molecule is made by aldol reaction. Or if we are able to recognize an alpha beta unsaturated ketone or aldehyde, then again this is an indication or a suggestion that the molecule is made by aldol reaction. And then so when we carry out our retrosynthetic analysis, we work with the aldol reaction in mind. And so that is the end of our discussion, and I hope you have enjoyed the session.